So this question asks, which gas law is represented by the equation PV equals nRT? And we have 5 different answer options, which represent 5 different gas laws. We have A, Boyle's law, B, Charles' law, C, Avogadro's law, D, the ideal gas law, and E, Dalton's law. So let's go through each of these gas laws, discuss what they mean, and determine the correct equation to identify which is represented by the equation PV equals nRT. And we can start with Boyle's law. So Boyle's law states that pressure and volume are inversely proportional at constant temperature, and therefore we can represent Boyle's law with the following equation. We have P1 divided by V1, so we have the initial pressure divided by the initial volume, is equal to the second pressure divided by the second volume, or in other words, the new pressure and the new volume. So we can see that this is not represented by PV equals nRT, and therefore Boyle's law is not the correct answer. Next, we have Charles' law, and Charles' law states that volume is directly proportional to temperature at constant pressure. So the equation for Charles' law is V1 divided by T1, so the initial volume divided by the initial temperature, is equal to V2 divided by T2, or in other words, the final volume divided by the final temperature. So again, we can see that this is not represented by the equation PV equals nRT, and therefore Charles' law is also not the correct answer. Next, we have Avogadro's law, and Avogadro's law states that the volume is directly proportional to the number of moles at constant temperature and constant pressure. And similarly, we can represent the equation for Avogadro's law as follows. We have V1 divided by N1, so we have the initial volume divided by the initial number of moles, is equal to V2, the final volume, divided by N2, the final number of moles. And once again, we can see that this is not represented by PV equals nRT. So Avogadro's law, like Charles' law and Boyle's law, is not the correct answer. Then we get to the ideal gas law, which is indeed our correct answer. The ideal gas law relates pressure, volume, the number of moles, the gas constant R, and temperature all into one single equation. And that is indeed what we see through the equation PV equals nRT. We have P and V representing the pressure and volume. We have N representing the number of moles, R representing the gas constant, and T representing the temperature. So again, answer option D is indeed correct. This is the law that is represented by the equation PV equals nRT. But lastly, we have Dalton's law, which we already know is incorrect, but let's briefly discuss it. Dalton's law, which is also known as the law of partial pressures, pertains to partial pressures in a gas mixture. And we can represent Dalton's law with the following expression. We have the summation of all of the individual partial pressures, which is equal to the final partial pressure. So we have, for example, the P total will be equal to P1 plus P2 plus P3, and so on. So all of the individual partial pressures sum to create the total pressure. But again, this is not represented by PV equals nRT, and therefore E is not correct. So the correct answer option is D, the ideal gas law.